Good afternoon and good evening, everyone. I'm so excited that you're able to join us today, and welcome to the webinar Evaluating Technologies for CO2 Removal and Building a Robust Carbon Offset Strategy. My name is Cecilia G. I'm an analyst here at Lux Research, and I will be moderating today's session. And presenting today, I am very excited to announce is my colleague Mukunda Kaushik, analyst here at Lux Research as well. Now, throughout the webinar, you can type any questions you have in the questions box on your screen. Time permitting, we will answer all the questions that we can. If your question does not get answered, please do not hesitate to email it to questions@luxresearchinc.com. That's questions@luxresearchinc.com, and we will respond. Now, without further ado, let us jump into the presentation. Mukunda, over to you.
Thank you, Cecilia. Now, over the last few months, Lux Research has put out several reports on carbon negative technologies and also built quantitative tools to help our clients build a carbon credit portfolio. We know that one of the biggest conclusions of the 2022 IPCC report was that any net zero scenario will require CO2 removal in addition to any direct emissions reduction. Now, there are several pathways for direct emissions reduction, whether that's electrification, fuel switching, or even carbon capture from your point sources. But several of these pathways will require time to set up and implement, or in many cases, take time to just become commercial. And carbon credits, while often touted as that last resort solution, can actually help companies manage their near-term emissions and buy time, so to speak, as these other decarbonization alternatives become available. So if you work with the right carbon negative technologies today, you can actually still use carbon credits to your benefit. But how do we analyze which carbon credit generating technology is best to engage with? What signs of development should you watch out for, and how can you safeguard your company from the associated risks of carbon credits? These are some of the questions that we'll answer in today's webinar, and we'll start by reviewing the Lux Carbon Negative Framework, and then we look at balancing costs and risks through the lens of recent market developments and some case studies, and end with some conclusions. So starting with the Carbon Negative Framework, this figure shows you the global carbon cycle as it exists today. You'll see the natural carbon cycle on your left, and then the human or industrial carbon cycle on the right. Now, there are three ways in which you can use carbon negative technologies to intervene with this global carbon cycle and redirect the flow of CO2. The first is refossilizing carbon, where we remove already emitted atmospheric CO2 in such a way that it is permanently removed from circulation in both the natural carbon cycle and the human carbon cycle. A good example here is direct air capture coupled with storage. The second type of intervention is what we call complementing the natural carbon cycle. Now, the industrial carbon cycle will always require a source of CO2 or a source of carbon for a range of applications, but we'll increasingly need to source that CO2 from a non-fossil source. So can carbon negative technologies really help with meeting some of that demand and provide a source of CO2? The third is augmenting the natural carbon cycle. Here we stay with the fact that the industrial cycle will require a source of CO2, but can we tap into CO2 circulating in the natural carbon cycle and redirect it into the industrial carbon cycle? So a good example here is forestry, which can be a source of biomass, for instance. And in this report, we identified 11 carbon negative technologies that span CCUS, land-based solutions, and ocean-based solutions that fall into one or more of these types of interventions. And what's interesting here is how you actually evaluate these technologies. And in doing so, we need to look at both the cost and the risks. And that's what we'll focus on for the next part of this webinar. Now, this figure plots the 11 technologies that we saw earlier based on cost on the x-axis, which is the price at which that carbon credit is sold today on the voluntary market, and the composite risk on the y-axis. Now, we'll keep coming back to this figure, but to fully understand it, we have to look a bit more closely into the meaning of what we call composite risk. This is an aggregate of 4 different factors. The first is the risk of carbon re-release. right? So the goal of removing CO2, as we saw in the framework, is to either permanently lock it away or redirect it into a flow of your choosing into the industrial cycle. A forest fire does neither and poses a strong risk of carbon re-release for several land-based solutions. The second is the risk of advancing regulations, right? So a good example here is the expansion of the EU ETS to regulate emissions from road transportation. And there's also talk of banning the sale of ICE vehicles in 2035. If this does in fact happen, electric vehicle manufacturers and charging station developers will no longer be able to generate and sell carbon credits from the avoided emissions of electric vehicles, right? So, in other words, Tesla's $1.8 billion revenue from the sale of carbon credits in 2022 will be heavily impacted. The third risk is that of imprecise quantification, right? So, can you actually verify how much CO2 you're removing as a function of time? And this figure here shows the satellite imaging of a wetland project where you can see the ton of CO2 removed per hectare of land falling to about 50% of its capacity in 10 years. If you don't accurately quantify this while the project is actively generating credits, newer digital tools can debunk the credits that you're selling. And the last component of composite risk is societal backlash. Now, people might be very happy with having more trees or electric vehicles in their backyard, but they might be less happy with having their land dug up to install a CO2 pipeline. Right? So, how does a technology fare in the court of public opinion, and will there be societal pressure in stopping new project development? Each of these risks is very real and very prominent in the carbon market today. And because they are unaddressed, a lot of consortia and stakeholder driven investment groups are introducing limitations and bans on carbon credits. So, coming back to our figure, a composite risk over 2.2 indicates that at least two of the four risk factors that we looked at have a significant impact on that technology. And a number of technologies sit above the 2.2 line, so the need for risk reduction is quite self-evident. But on the other hand, we also have to factor in costs if we're looking at the affordability of these credits at scale. So it's really important that cost reduction and risk mitigation happen hand in hand. Now, the good news here is that these bubbles are not static, and there's been a lot of development within the CO2 removal market in the last year. And when we condense all of that activity, we're basically left with three types of market developments that can either reduce risk, reduce cost, or ideally reduce both. And what are these three types of activities? The first is new pilots and demonstrations, which has a direct impact on cost reduction, specifically for technologies that are actively scaling in capacity. But the focus of new pilots and demonstrations is to validate the technology and scale operations, not to reduce the risks of that technology. So the direct impact on risk reduction is quite low. The second type of activity is technology innovation. Now, this is not just the emergence of new CO2 removal technologies like ocean-based solutions, for instance, but also new ways of running incumbent technologies, for instance, electrifying processes that might be heat-driven in the incumbent pathway. But then again, the impact on risk reduction is not as high, and we categorize it as a medium. And why is that? It's because innovation in peripheral technology can reduce the risks of the core carbon negative technology. For instance, if we deploy better continuous or dynamic pH sensors to measure ocean acidification, that would help reduce the risks of direct ocean capture for both quantification and societal backlash, studying the impact on marine ecosystems. But the technology innovation is coming from the sensor and not direct ocean capture. Hence, we classify it as a medium. The third is MRV and regulation. MRV refers to measuring, reporting, and verification. And it's a common acronym that you will hear both today and broadly in this ecosystem. It really refers to having a process in place to measure the CO2 removal of that project, report that CO2 removal over a period of time, and then verify your CO2 removal and your findings through an accredited third party. It's also important to note that governments today don't regulate MRV, so all of it is voluntary. MRV and regulations are critical and has a direct and high impact on risk reduction. less so on cost, other than what governments might be doing to subsidize some of those CO2 removal technologies. If we look at these three clusters of activities today as a whole, the takeaway here really is that there's more of a push towards cost reduction than towards risk reduction. Project developers are focused on getting their technologies up and running, scaling, and reducing costs. And that is no doubt important, extremely important. But as a company looking to offset emissions, that risk profile really can't be ignored. So now that we understand what risk means in the context of a carbon credit, and we know what developments or what type of developments are ongoing, let's look at a few examples within each class of carbon negative technologies. So CCUS, land, and ocean, starting with the CCUS side of things. So this is where we see the most amount of activity, given that these are engineered solutions yielding what you can call high quality credits. In terms of new pilots and demonstrations, there's a booming capacity pipeline for direct air capture through the decade and beyond, spanning both large-scale efforts and smaller pilots. We're also seeing new demonstrations and techniques that are refossilizing carbon by storing CO2 in concrete, in basalt rocks, and also sequestering high-density pyrolysis oil in Class 6 wells. The last one being demonstrated by a company called Charm, that's currently valuing its credits at about $600 per ton and expecting to have a cost reduction of about 37% by 2030. On the technology innovation side of things, I'm sure it comes as no surprise to a lot of you that we're seeing a huge wave of new entrants for DAC, and with the innovation landscape no longer being defined by just the incumbents. And we're also seeing bioenergy with CCS or BECCS projects really experiment with their capture technology, not just working with amine solvents, but also metal organic frameworks and membranes and such. And all of this sounds great from a cost reduction perspective, but what makes CCUS even more interesting within the carbon negative ecosystem is the developments within the risk. Today, both direct air capture plus storage and CO2 mineralization in concrete have validated MRVs that you can see publicly and also follow for your own project. So this puts the two technologies at one of the lowest risk tiers possible. And we expect a lot of companies to take advantage of these MRVs and expect the momentum to continue. Now, there's a lot of activity here, of course, but let's take a look at two developments in particular from Carbon Cure, which adds CO2 to a wet concrete mix to mineralize it. Carbon Cure already has hundreds of operational facilities, but more recently had its methodology validated and disclosed on Vera. And according to this company, it has already delivered about 70 kilotons of carbon credits based on its methodology, with the average ticket volume being about 5 kilotons. You should look at this development quite positively because CO2 curing in concrete already has relatively low technology barriers. If companies like Carbon Cure can figure out the MRV and the risk side of the coin, it becomes a very attractive, high quality carbon credit. So now, while something like mineralization is going well, there are other technologies that have taken a hit on the risk side of things. And we see that when we come back to our figure here. CO2 mineralization is fast approaching that favorable side of things, but something like bioenergy with CCS is actually increasing in terms of risks, mainly because it will rely very heavily on regulatory support. If BCCS is to compete with utilities that are developing wind and solar, it will need regulations and their local governments to recognize BCCS as a carbon negative technology and provide some type of a credit or a subsidy. And we see Drax, for instance, fighting with the UK government a little bit. It's been a bit back and forth. And now they've received approval, but a similar challenge will hold true as they expand to other regions. So BCCS is actually increasing in terms of risks, and the cost reduction is largely attributed to the cost reduction of the carbon capture technology. Direct air capture and sequestration are also following a similar trajectory. We don't expect these costs to ever compete with something like forestry, because if a technology is going down the risk scale, it will command a premium, and that's where the CO2 solutions are at today. But switching gears to land-based solutions. For land-based solutions, there is less of a need to drive down costs because they're already quite inexpensive, but they carry a very high risk. And that risk is demonstrated by recent developments at Vera, which listed about 95 million credits through its forestry projects. But just earlier this year, an independent study concluded that about 94% of these listed credits did not amount to meaningful CO2 removal. Now, there are several contributing factors to this: overcounting, unaccounted deforestation, and other social externalities, just to name a few. But as a result, Better had to suspend certain projects and is in the process of revamping its methodology, which will only be enforced 2025 or after. Now, this is a major example, but it's not an isolated incident, and that explains why high risk carbon credits, no matter the affordability, will carry a very high liability for corporate offsetting. So this means that forestry is actually moving towards an unfavorable direction and higher up on the risk scale, which is not very favorable. And lastly, looking at ocean-based solutions. Now, this is a much newer technology category for carbon credits, but one that's actually moving quite fast. Ocean-based solutions spans engineered solutions like direct ocean capture, but also approaches like sinking biomass or enhanced weathering. So let's go through the same process where we look at the developments. For new pilots and demonstrations, the activity to note here is really on the direct ocean capture side of things. Equinor is supporting a biomass sinking project, but there's not much traction apart from that. Direct ocean capture is basically the ionic rearrangement of the components of seawater. Um, so a lot of these companies are transitioning from the lab environment to less controlled environments in the ocean. So that's a positive sign to look out for. Another thing to note here is regional expansion. Right? Companies that were almost exclusively in the US are now eyeing expansion in Singapore, the Middle East, and even Portugal to work with some of the existing infrastructure. For technology innovation, the most important piece to call out is the different products and byproducts that can be formed as a result of the direct ocean capture process. Now, you can either end up with no byproducts, or you can end up with things like high purity calcium carbonates to sell to various industries like glass and pharmaceuticals, or even the cement industry, or you can end up with hydrochloric acid or even low carbon hydrogen. And that's part of the reason we saw Boeing invest in a direct ocean capture startup, Aquatic, just earlier this year. And that deal will look to deliver about 62 kilotons of CO2 removal credits and about 2,100 tons of hydrogen, or low carbon hydrogen rather. MRV and regulations for ocean-based solutions are extremely nascent, but for direct ocean capture, specifically because it's an engineered solutions and mass balance driven, we're seeing developments in MRV that is worth noting. Startups are also publishing their MRV drafts for stakeholder review. So if you're not ready for an investment in a company or a project just yet, you can still engage with these startups to see how they're thinking about their MRV, and what they hope to gain. And that would be a good place to start. Looking at a specific example for deployment, right? So just in the last few weeks, 3 direct ocean capture companies announced scale-up efforts: Captura, Capture6, and Aquatic. The capacities of these projects are still small, barely getting into the kiloton per year magnitude, but there's still a fair amount of development required. But as you monitor the scale up of these companies and other DOC companies that will no doubt emerge, there are 2 things to look out for. As I was mentioning, their movement from controlled environments to more open ocean trials that can validate the technology. And second is the location of these new projects. So these startups are looking to retrofit their technology with existing infrastructure that processes seawater. So we're talking about reverse osmosis units, desalination plants, even power plants that use seawater as a coolant or as a heat transfer agent. So if you're looking at a lot of your legacy assets that you want to put towards new low carbon applications, that could be an easy entry point with direct ocean capture. So we see the general trajectory of both costs and risks going down for DOC. Um, Coming to some of our conclusions for the day, based on what we've seen so far, the first is really about timing, right? So carbon credits can help buy time for direct emissions reduction. It's not a substitute in any sense. And when alternative direct emission reduction pathways come into play, companies will have to find a way to essentially exit and retire certain offsets other than what they need for their scope 3 emissions. So working with low risk technologies, engineered technologies today can really help buy time, specifically if it has synergies with your other decarbonization strategies. The second is that risk mitigation is paramount, right? So carbon re-release, advancing regulations, imprecise quantification, and societal backlash are the four risks to consider. And because certain technologies like artificial upwelling or even biomass sinking are more affordable, we haven't seen any meaningful activity. And that's because the risk profile is really high. So you would rather invest in a low risk but slightly more expensive technology today that you can bring down the cost curve than work on a very high risk technology that the risk won't realistically come down in a meaningful timeline. And so any risk reduction efforts really have to sit separately from ongoing cost reduction efforts. And lastly, what can you expect in terms of costs? The price of offsetting will be hefty. So specifically, if we're talking about high quality credits, right? So anyone looking to engage should also look to engage early because these credits won't necessarily be available in abundance 2030 or after. The most common agreements today are pre-purchase agreements where future capacity for high quality credits are already being put out, and this will limit the supply of these credits in the voluntary market. So expect higher costs for engineered solutions and engage early because the premium of these engineered solutions will not disappear. And with that, we'll answer any questions from the audience. And please let us know if you have any additional questions about the technologies itself.
Fantastic. Thank you so much, Mukunda. What an interesting way to set up these technologies and create this framework that makes it clear and digestible on how to approach the entire space. And I know, of course, we have deep dives into many of these technologies as well. But for now, we will be taking questions that you might have on this presentation, which you can type into the questions box. And if we do not get to your question on this call, someone from Lux will be in touch after the webinar. And I've been seeing some questions coming in throughout this past while we've been together. And just looking here, there is a question around all the MRVs. So, of course, measurement, reporting, and verification. And what this person is asking is more so, what is the status of MRV for different technologies today? And how do we develop or see a methodology for a given carbon credit? What are your thoughts here, Mukunda?
That's a great question. So now, depending on the technology, right, you might not actually have to develop your own MRV and your own methodology for documenting CO2 removal. These documents are, if available, are publicly listed and available for you to see on the registries of Gold Standard or Vera. You can find historic MRVs for forestry, but a lot of project developers are starting to revamp how they actually go about their methodologies. So I would suggest looking at newer publications as opposed to something that might be over a decade old. For something like direct ocean capture, these methodologies have not been publicly approved yet by a third party, but the calculations are still available and startups can actually publish them on their website, for instance. So you might be able to take a look at that. But to go about actually developing an MRV, the first step is to really establish the boundaries of your system and really outline each step of your core process. For example, if you're developing an enhanced weathering project where your weathered material is coming from mining waste, right? You have to account for the emissions of that mining process. You have to account for um, emissions of transporting that weathered material from the mine site to the site of deployment. Now, if you see an MRV that doesn't include these stage gates in their methodology, you know that it's not a very good MRV, right? So establishing those boundary conditions is very important. Vera has also been revamping its MRV for biochar, for instance, where you can see very clear conditions on what pyrolysis processes are allowed and what are not allowed, what applications of that biochar can be considered for credits and what can't be. So those would be some of the resources to look at.
No, absolutely, and there definitely are resources, despite this being more of a voluntary basis. So I think that's one part in terms of the reporting, disclosure, verification side. Another question that I saw come in from the audience today was more so around cost. So of course, there's so many different technologies here. The question was, how expensive will carbon credits be, and what will be that cost of offsetting?
The $1 million question. So today, the range of carbon credits ranges anywhere from $3 per ton to about $2,000 per ton, depending on the technology, depending on the project, right? So in terms of affordability, the number we hear at Lux a lot is something within that $60 to $80 per ton of CO2 would be ideal and something reasonable to work with for the scale in which our clients look to offset. But the cost of offsetting, or rather the economic viability of offsetting, is more of an internal decision for a company rather than an industry standard that needs to be set, right? So I would actually point you towards Lux's carbon credit portfolio tool, which plots all of the technologies that we looked at today on our carbon canvas. The carbon canvas basically incorporates the available capital for your organization against your critical carbon price, which is the maximum carbon price that your company can afford. So it'll be more of a tailored tool that can show you which of these technologies will be viable for your organization. Because clearly, I think from what we've seen in the webinar, just because forestry credits can be $10 per ton and a company can afford them, doesn't mean that that's the solution to offset, right? So likely you'll need a portfolio that incorporates a few different technologies, just different in proportion, depending on your need.
Absolutely. And I think those are a lot of the discussions that we do have with Lux clients, just to give a flavor of some of the discussions is, what does that look like for a decarbonization pathway or a net zero pathway? And what strategy are you taking? Can you essentially, as you mentioned, buy yourself out? Or will you be innovating yourself to stay ahead of the pack so that you don't need to necessarily actually use up your capital and your cash flow to buy credits and offsets? So we are coming up against the time that we have today. Then unfortunately, sadly, I think this is where we will have to conclude things. So thank you so much, Mukunda, for the presentation and for your thoughts around the questions that had come in. And that concludes our webinar for today. The slide presentation and recording from this webinar will be sent to you via email later on. And after leaving the webinar, you'll be prompted to complete a survey on today's presentation. We would, of course, appreciate any feedback you might have to help inform and improve our future webinars here at Lux. So, of course, take a moment to check out some of the upcoming webinars that we also have. Something that could be timely is our upcoming one, building a net zero oil and gas company. This is really taking a look at what are the key strategies that an oil and gas company can take to get to net zero in 2050, and understanding what that mix looks like. What are some of the pros and cons? What are the barriers and opportunities? But in the meantime, thank you so much for joining us, and have a great rest of your day or evening wherever you are in the world. Thank you very much.
Thank you.
Thank you.